everybody. How you doing? Excellent. My name is Michelle Nichols, and I'm the Director of Public Observing at the Adler Planetarium. I'm in charge of all the Adler's telescope and sky observing programs and events. I run the observatory, and I'm in charge of all the Adler's solar eclipse events coming up, or the big eclipse event coming up on Monday, April 8th. I do programs like this at libraries on my own time, because if I did this as part of my job, around events like this, it'd be the only thing that I did because there's been a lot of interest at libraries, especially because everybody remembers the craziness of 2017 and they wanted to get ready for 2024. So I've been giving talks since last summer about the eclipse that included the October eclipse that none of us saw because it was completely cloudy that day. Pretty similar weather conditions as to what we've got right now. So none of us saw that one, not here in Northern Illinois. Actually, most of Illinois did not see that eclipse. Most of the upper Midwest did not see that eclipse. So if you're thinking to yourself, I don't remember that one, don't worry, we didn't see it. But we hope the weather is better on Monday, April 8th, 2024. This will be the last total solar eclipse in the lower 48 states until 2044. There will be other solar eclipses between now and then, but this will be the last total visible in the lower 48 United States. And that particular one won't be visible at all in Chicago, not even a partial eclipse. So the next total solar eclipse occurring in the lower 48 that is also visible as a partial solar eclipse in Chicago is, I believe, 2045, 2046. You know, mark your calendars, right? And the next time that Chicago proper, you draw the boundary outlines of Chicago, the next time part of Chicago will see a total solar eclipse, as in totality occurs in Chicago, 2099. So that's why people are really paying attention to this one, because it's happening soon and we don't have to wait literally 70 years to be able to see one happening over our heads. But I'm going to tell you all about what to expect if you're going to stay in this area and see it versus those of you who might be traveling to go see totality somewhere. Is anyone planning on traveling? A few, holy cow, all right, cool. I'm gonna show you a few resources for information for figuring out exactly what to expect for where you are. I'm also gonna talk a bit about why solar eclipses are relatively rare. That word gets thrown around a lot online. Practically everything you see online, if it has to do with the sky, somebody has attached the word rare to it. So it gets overused, but I think we can pretty easily claim that solar eclipses are relatively rare, but I'm going to explain why. And then at the end, we'll talk about ways to safely view the eclipse. And actually, I wanted to grab a couple things out of my bag before I forget, because I'll need these to show you a few things. All right. And then we'll definitely have time at the end for questions. Those of you online, they have the meeting chat, right?
Yes.
So those of you online, go ahead and as you think, I'm talking to the camera right here. As you think of questions, throw them in the chat and I will get to the chat when we get to the end, but you don't have to wait to the end to type a question in. So even if I end up answering it later, just go ahead and put the question in. That is totally fine. For those here in the room who are planning on traveling to totality, where are you going approximately?
Indianapolis.
Indianapolis?
Going to Richmond, Indiana.
Richmond, Indiana, all right.
Don't know, maybe south of it. Indianapolis.
Okay, south of Indy. Okay, yeah. Traffic determined. All right. What?
Poplar Bluff, Missouri.
Poplar Bluff, Missouri. I talked to someone last night who's going to Missouri also. Anybody else? You got everybody? Okay. So those of you online, some of you might be traveling to totality as well. There will be ways to view this eclipse online if you're not planning on traveling and you want to see totality. NASA is going to be doing a giant online presence for this eclipse, getting live feeds from, I believe, 8 or 10 different locations along the entire path where you're going to potentially see totality. So if you're not traveling, but you want to see it, just go to nasa.gov on Monday, April 8th, and you'll be able to watch that, live broadcast. I think it starts at 12 noon Central. Don't quote me on that. Definitely check the website. I don't know if they've actually announced what time it starts. But that's a great resource to remember. All right. Ready to get started? Okay, let's
The
get started.
library will have the NASA.gov live stream up on the big screen.
Excellent. Excellent.
Could it be cloudy here?
Yes, which Monday, April 8th. April, for all we know, it could be 70 degrees out, it could be 20 degrees out. It could be bright sunshine, it could be completely cloudy. It's just spring in the Chicagoland area. That's what we get. Okay, so I'm going to share my screen.
Sorry to interrupt.
Yes.
We have two of our online participants, Stacy and Steve. Stacy is going to Carbondale.
Oh, great.
And Steve is going to Hot Springs, Arkansas.
Excellent. Oh, so you said Stacy is going to
To
Carbondale?
Carbondale.
Excellent,
And Steve is
Stacy.
going to Hot Springs.
Stacy, I might see you in Carbondale because that's where I'm going to be in the football stadium at Southern Illinois University. So that will be a lot of fun. So hopefully, Stacy, if I see you, then definitely come and say hi. Okay,
Isn't that only like 10% will be showing there?
say again, sorry.
Isn't that only like 90%?
In Carbondale? Nope, 100% totality there. Yep. So yes, they're gonna throw a big party down there. All right. So let's first talk about why solar eclipses are relatively rare. Okay. So boy, it helps to put the actual controller into your computer, Michelle, when you want to actually use the clicker properly. So there we go. So hang on. There. So the moon goes around the earth. Not a surprise. The moon goes around the earth about every 29 and a half days. And approximately. So solar eclipses occur when the moon gets in between the earth and the sun. Lunar eclipses occur when the moon passes through the shadow cast by the earth in space. We'll talk more about lunar eclipses in just a few minutes because they are connected to solar. But anyway, you would expect every time the moon goes around the earth and gets in between at the phase of the moon we call new moon, you would expect a solar eclipse to occur, but that doesn't happen. So I'm going to explain and show this animation right here. So the animation that you've got on the screen, I'm going to use my arrow so that the folks at home can see what I'm pointing at. The dot in the middle is the earth. The little tiny dot on the outside is the moon. If you're having trouble seeing either of those, it's kind of the point. This is to scale or close to it. So often when you see the moon and the earth portrayed together in an image, it's wildly out of scale because people want to portray it so you can see it. But if we shrink the earth down to a 1 foot wide ball, the moon would be a 3-inch wide ball 30 feet away. So might fit at the back of the room, possibly, might not. You might even need a little bit more space. So that's kind of hard to portray in a small image. But anyway, let me get this animation going. So the moon goes around the earth. This is greatly sped up. So what it's going to do is it's going to stop at that new moon phase, except the moon's orbit is tilted with respect to the earth. So normally the moon's shadow misses the earth. It either passes above it or below it. But the moon's orbit does kind of wobble a little bit. And on average, a couple times a year, you'll have the moon's shadow pass over the earth as the moon does get directly between the earth and the sun. So on average, solar eclipses occur a couple times a year. You can have them be as many as 5 times in a year, but that's actually pretty rare. But the whole point of this is, yes, they're rare. They only occur a couple times a year. And if you're thinking to yourself, wait, I don't remember solar eclipses occurring twice a year in this area. That's because you might not see either of them. You might only see one of them. You might see both. You might see all the solar eclipses that occur that year. You might not see any for several years. So they are relatively rare. Now, the other interesting thing is the moon's shadow, when it reaches the earth, is small. It doesn't cover the whole earth. So even folks who are also facing the sun when the eclipse is occurring, if they're outside the region of the moon's shadow, they won't see the solar eclipse. So I'll show you an example of that when we get to the animation for this particular eclipse on the slide after this one. But I'm going to start this particular animation. Now, this one was done for the 2017 eclipse. So we're going to take a look from kind of the moon's perspective here. The far side of the moon during new moon is the side that's lit up by the sun. The side facing us is the side in shadow. Now, take a look at the shadow itself, okay? So the shadow itself is this dark inner shadow. And then if I press play and just let it go a little bit longer, you'll see a yellow circle. You see the yellow circle here? That's the moon's lighter outer shadow. So two-part shadow, a darker inner part and a lighter outer part. The darker inner part, and you can see it portrayed with that circle there, right there on the ground. The darker inner part is where you need to be to see the moon briefly cover the sun at 100%. When I use the word totality, that's what I'm talking about. That yellow outer circle delineates the moon's lighter outer shadow. In those regions, you only see a partial solar eclipse. The moon only partly covers the sun. The closer you are to the darker inner shadow, the more of the sun is covered by the moon. The closer you are to the edges of the shadow, the less of the sun is covered by the moon. And if you're outside the shadow, you're not viewing the solar eclipse. So I'm going to keep this going. Now, the solar eclipse totality, as we say it, 100% coverage, occurs in that dark inner shadow region. Notice how small that is. In 2017, that region was only 78 miles across. In 2024, it's a little bit bigger, and I'll explain why when we get to the next animation. But as we trace where the shadow passes over the earth, we draw a path to indicate that region where you need to be to briefly see the moon cover the sun at 100%. We call that the path of totality. But the amount of time that that dark inner shadow region is over you is brief. So the amount of time for the 2017 eclipse was a little over 2 minutes in length, maximum. For the 2024 eclipse, it's going to be a little over 4 minutes in length, and I'll explain why in just a bit. But this is also to scale right here. So it just goes to show you, by the time that dark inner shadow region is actually at the earth, it's pretty small. Okay, now this animation is for the 2024 eclipse. Actually, hang on, I'm going to go back real quick. I'm going to show you one quick thing. Notice for the shadow animation, you see for 2017, it went from northwest to southeast. You see that? All right. So for the 2024 eclipse, it goes from southwest to northeast. So solar eclipse paths don't always take the same direction. Why does it have a different direction? The moon's orbit is tilted. Sometimes it's tilted this way and sometimes it's tilted this way. So that's why you get different orientations of where the shadow is going across the face of the earth. Okay, so let's take another look. So the shadow is coming up through the Pacific Ocean, up through Mexico. That red circle region is where you see totality. And that's going to come up through Mexico, up through Texas, up through Arkansas, Missouri, up through Southern Illinois, Indiana, Ohio, and out toward the Northeast. So the dark inner shadow region for this eclipse is a little bit bigger. So 115, 120 miles across, something like that. Why the difference? The moon's orbit around the earth is not a perfect circle. Sometimes the moon is a little closer to the earth and sometimes it's farther away. So for the 2017 eclipse, the moon at that point was about 231,000 miles away. For 2024, the moon will be about 223,000 miles away. What does that mean? It's a little closer. The shadow's a little bigger. The amount of time it takes for that shadow to pass over you takes a little bit longer. So that's why totality is a little bit longer, right? So let's look at this one more time. So where you see the colored circle, for whatever reason, they decided to use several different colors, but it's really just that whole outer shadow region is delineated by that whole circle, and just that red area in the middle, that's the totality region. And then the moon sweeps over, or the shadow sweeps over the surface of the earth, falls off the edge of the earth, eclipse is over. All right. So
Why do they give you so much time between the possibility of when it will happen to,
I'm not sure I understand your question.
the time that you're, I guess, wearing the glasses?
Okay.
Is quite a bit of time between 12:51 and 3 o'clock.
Yep, I'll explain. I'll get to that. I'll get to that. I anticipated your question. I'll get to that in a few slides. All right. Now that I'm showing you the wildly not to scale image, it looks almost comical compared to the to scale images I showed in the animations. But the reason I'm pointing this out is the orientation. If it's right for a solar eclipse, it's right for a lunar eclipse. And there is a lunar eclipse associated with this solar eclipse. And yes, that lunar eclipse is occurring in this area. We'll be able to see it. I'm here to tell you not to get too excited about it, and I'll explain why. So this animation, again, wildly not to scale. I'm going to jump forward in it, and I want to bring up a few words. So the Earth's shadow and the moon's shadow consist of two parts. The dark inner part is called the umbra. The lighter outer part is called the penumbra. And all that comes from the same root word where we get the word umbrella. It means to block or to shade. And so if the full moon passes into that dark inner shadow, fully within it, you get a total lunar eclipse. That's where the moon turns that red or gray or orange color, or brick red color. We had a couple of them occur a couple of years ago. We had one in November of 2021, one in November of 2022. Gorgeous, beautiful lunar eclipses. If you have the moon only pass through part of that dark inner shadow, we call that a partial lunar eclipse. And sometimes the moon's orbit takes it right through the inner shadow. Sometimes it only clips the shadow. Sometimes it only passes through the lighter outer shadow. That's called a penumbral lunar eclipse. The kind that's occurring in about a week and a half or so, that's that kind, a penumbral lunar eclipse. And so what are you going to expect? Well, March 24th, starting at 11:53 p.m. to 4:32 a.m. on March 25th. So this is the peak of the eclipse is occurring at 2:12 in the morning Central Time. So right now you're thinking to yourself, do I need to stay up for this? How badly do I want to see this lunar eclipse? Well, let me give you the full expectation, and you can decide for yourself if you want to stay up for this one. I will cut to the chase. I'm not staying up for this one. So this is the greatest extent of this particular eclipse. And so what you're seeing is the full moon is passing only through the lighter outer shadow. So it takes about 5 hours, close to it, for it to fully go through and come back out. Not even the entire full moon is going to get within the lighter outer shadow. So what does it look like at its maximum? Well, the next slide is going to show you a prior one of these eclipses. And actually, for those of you watching at home, you're getting probably the more accurate view. The video projector here is showing it slightly too dark. So the amount of shading is minimal. Where exactly the moon gets shaded is slightly different for this next eclipse, but it's okay, close enough. But the amount of shading is very minimal. Now, why am I harping on this? First off, We do have a partial lunar eclipse coming up September 17th. We don't get to see the solar for that one. We have a total lunar eclipse coming up in March of next year, 2025. We have this one occurring in March of 2024. The other reason, so I want you to look forward to those other two. The other reason I'm kind of harping on this one is I fully expect there to be a clickbaity article out there somewhere that is going to use some stock photo of a lunar eclipse. And which photo are they going to use? One of those really bright red lunar eclipse photos. And I see several of you nodding going, yeah, I've seen them do that before. They definitely use those photos even when it's not actually portraying the right thing. And they'll say, lunar eclipse, don't miss it, rare, rare. Yeah, sleep in, it's okay. If you happen to be up, great. If you want to see it, to say you've seen one, fantastic, be my guest. But I just wanted to give you the full amount of information as to expectations. And then look forward to the one in September or in March of next year. All right. Now, here's what we can expect for the solar eclipse on Monday, April 8th, 2024. So the lunar eclipse happens first at full moon, and then at the following new moon, that's when we get the solar eclipse. So in northern Illinois, at its maximum extent, so far northern Illinois, at its maximum extent, about 92-93% of the sun is covered by the moon. To compare to 2017, that was about 87% in our area. And then the farther south you go, the more and more of the sun is covered by the moon until you get to this path delineated by the dotted lines here, where you get to see totality, hopefully, if it's clear out. The yellow line in the middle is the center of the path of totality. We encourage people who are going to see totality, try to pick a spot that's close to the center line if you can, just to maximize your amount of time for totality. So the maximum amount of time is at the center. The closer you get to the edges, the shorter totality is because you just have less moon shadow passing over you. It doesn't take as long. But even 2/3 of the way out to the edge of the path, you've still got over 2 minutes of totality. It's pretty good. It's only when you get to the really far edges is when you get more about tens of seconds of totality. But I'm here to tell you, even 1 second of totality is worth it. It really is. But on the flip side, if you know anyone who lives at 99%, please encourage them to drive those few miles into the path itself, because 99% is not 100%. 1% of sun is still too bright to allow you to see everything that you see during totality. So that's why I encourage people, make sure, first off, that you pick a spot where they're actually going to see totality, and then try to maximize your time if you can. It also depends on the clouds. And if you find that the clear spot is going to be the spot that only sees 15 seconds of totality, do it. All right, by all means. Whoops. So by all means, definitely do that and get to where you're going to actually see totality. All right, now this is to explain your question about why you need to wear those solar glasses for so darn long. And it's because it takes for our area, it'll take about 2.5 hours for the moon to completely pass over the sun. So starting at 12:51 p.m. Central Time, and these times are good for our area. Around here, it's actually more like about 12:50. These times are good within a few tens of seconds. I did the timing for the Adler planetariums location, close enough. So 12:51, 12:50, whatever. You've got the moon just starting to peek over the edge of the sun, all right? And it will slowly pass over the sun. And it will take a little over an hour for that to happen. Then at 2:07 p.m., that's the maximum extent, 94% for our area here. The moon continues to pass over, and then 3:22 p.m. is when the eclipse is finished. So it's not like, boom, 94% coverage. There you go for 2.5 hours. It actually takes time for the moon to completely pass over the sun and exit. So again, about 2.5 hours total. And those folks who are located farther from the path of totality, their partial eclipse timing will be shorter. closer you are to the path of totality, your solar eclipse time is longer. Until you get to totality, where you got over an hour for the moon to get to the totality point, and then you've got up to about 4 minutes or so of time for totality itself. So long period of getting up to that point and a short period of time for totality itself. All right. Something you can look for. Something you can look for in our area, because we're going to have the sun covered well over 50% at maximum. So this is something you can start to look for when the sun is covered by at least 50%. And that is, I want you to start looking around at your shadows. Something that you might notice in the room, look down at the floor and look at the shadow of the table on the floor. If you can see it, table, chairs, you, all that. Do you notice how fuzzy edged the shadows are? Have you ever noticed that? You probably see portrayals in drawings and paintings of shadows with very sharp edges. Shadows are very fuzzy edged. And that's because our light sources are usually very extended. These light sources are this big. The sun is an extended light source in the sky. That creates fuzzy edged shadows. As you start to stop down the amount of light from the sun, the edges of our shadows get sharper and sharper. So at least 50% coverage or more of the sun, look around your shadows. Take pictures. Enjoy that. And because that's something that we can all check for. And it looks really interesting because that's something we normally don't see. You don't realize how fuzzy edge shadows are until you see them sharp. So definitely look down as much as you're looking up. For our area up here, anywhere outside the path of totality, you will not be able to look at the sun directly with just your eyes. You will have to use the solar glasses in order to safely view the sun directly. There'll be no point you'll be able to look directly at the sun safely, okay? Only during totality, only those folks are gonna be able to look at the sun directly without solar glasses. And you're gonna have to look at it without solar glasses because the sun's light during totality is not enough to get through these glasses. It's not bright enough, which is kind of the point. I'll get to more of that about that in a second. Now, this particular video clip, I'm going to turn the sound down, make sure that doesn't play. And I'm going to hit play. And this video clip was, I believe, filmed for during the 2017 eclipse, or at least a recent one. And this is not sped up. This is at real time. Occasionally, you're going to see a bug flying across the screen. So what this is a camera pointing at a white sheet or a white piece of paper, something like that. And this was starting at about a minute prior to totality. So this is for the folks going to totality. This is something you can look for after you notice the fuzzy edge shadows. Look at your time, about a minute prior to totality. Start looking for this. I want you to put a white sheet down on the ground. Just go to Walmart and get a cheap white bed sheet. Put it down on the ground. And about a minute prior to totality, start watching that sheet. What you're going to start to see, I see the bug there, right there on the screen. Do you start to see the ripples? You see the ripples on the screen? They're very faint to start with. And those of you watching at home, you should be able to see it. So they're very faint. And then they get a little darker. They get a little darker. These are called shadow bands. They may or may not be visible for the next eclipse. It's kind of hard to predict if they might be visible or not. We did see them after the 2017 eclipse. We absolutely saw them. I saw them with my own eyes. It was really neat. What you're seeing is when the sun is just a tiny sliver of light in the sky. The sun's light is shining through different temperatures and different densities of air above you. And that's creating ripples of light on the ground. And you've seen this phenomenon before. If you're thinking to yourself, wait, but I've never seen a total solar eclipse before. But you've seen the phenomenon. If you've seen the sunlight shining through a pool of water and you see the ripples of light on the bottom of the pool, similar process. And so that is called shadow bands. You can look for it from about a minute prior to totality up to about totality, and then just after totality up to about a minute or so after totality. So that's something you can look for our totality travel folks. All right. About 3 seconds prior to totality. So this is where knowing your exact totality timing is key. About 3 or 4 seconds prior to totality, you get those last little tiny bits of sunlight shining through mountains and valleys that are on the edge of the moon. And it breaks the sunlight up into these little tiny dots. And that's called Bailey's beads. If you know the timing of where you're going to be for the eclipse exactly, all the estimates that you're going to see online are plus or minus 3 or 4 seconds. That's the most accurate that we can get any eclipse prediction is within 3 or 4 seconds. So when I say wait till about 3 or 4 seconds prior to totality, you're going to have to try to guess a little bit because the predictions that you're going to see are all within 3 or 4 seconds of accuracy. That's the best we can do with that. Although you got to admit that's pretty good to be able to do that. Anyway, so you start to see those little tiny dots of light. You can look for maybe a second or two. 1 1,000, 2 1,000. If you're still seeing the little dots, put your solar glasses back up. But you can try to see Bailey's beads very, very briefly. Do not stare at the sun. Remember, you don't stare at the sun any other day of the year. Don't stare at it during an eclipse either. The bright part of the sun, that is. So then totality hits, and this is what folks are traveling to see. This is what they hope to see. And what you're seeing is the shadowed side of the moon, which is the side facing us. The bright part of the moon is the side, the far side. And the white streamery looking stuff, that is called the corona. The word corona comes from the Latin word corona for crown, because that's what it looks like. So people named it about a couple hundred years ago before they really knew what this was. But it's the outer atmosphere of the sun. And the shape of the outer atmosphere of the sun is determined by the sun's magnetic fields. Whatever they're doing determines whatever the shape is that you're seeing in the corona. So what you see here may or may not be what the shape of the corona is on April 8th, 2024. So the corona is only about as bright as the full moon in the sky. So that's the amount of light that makes it safe for you to look at. So you absolutely do not want to be looking through the solar glasses at the corona. You won't see it. I absolutely heard stories of people who didn't know that in 2017 and kept the solar glasses up the whole time in totality. So they never saw totality, even though they were there. So
when does this take place?
Sorry?
What, from totality, when does this take place?
This is at totality. This is during totality. This is visible during totality. So the whole time during totality, this is what it'll look like approximately. So, all right. And by approximately, I mean the shape of the streamers. It might be more round. It might be more streamery. It might be more oblong. The exact shape of the corona might be a little bit different, right? Okay. You might also notice there's a dot over here on the left-hand side. There are going to be some planets that are visible in the sky at the same time. So you want to look for that too. But I'll get to that after this slide right here. What you're going to see is a darkened sky, not a dark sky. This is not a pitch black sky. There's still a fair amount of light around. So it will be a darkened sky. The shadow is above you at that point. The horizon might look a bit more lit up, but the sky above you will be fairly dark, and you might see some of the planets that will be visible in the sky too. Notice there's another dot over here. I'm going to go out on a limb and say both of those pictures, each of these is different eclipses, that both of them were probably Venus. That'll be the easiest one to see. And yes, Venus will be visible. So to the upper left of the sun and moon will be Jupiter. I'll get to what that other thing is in just a second. Then closer to the sun, Mercury. Down and below to the right, Venus, that'll be the easiest one to see. Jupiter will be the second easiest one to see. Then Saturn and Mars down to the lower right. What that other object is, it says Pons Brooks 12P. Does anyone know what that is? It's a comet. Don't get too excited. It probably won't be visible during totality for a variety of reasons. Number one, it's relatively dim. So you probably would need binoculars in order to see it. I do not recommend using binoculars during totality to try to see a comet that you probably won't be able to pick out. Do not waste your precious totality time looking for a comet. Besides that, you also don't want to get distracted looking for it and have the bright part of the sun reappear while you're looking through the binoculars. So just don't chance it. Don't do it. However, I will tell you that there is a way where you can at least maximize your chances of seeing potentially all 5 of these planets. Because Jupiter, Venus, no problem. Mercury, might be harder. Saturn, Mars, might be a little harder. The reason I'm saying that is because you've got about 4 minutes of totality at most. It takes usually 20 to 30 minutes for your eyes to fully adjust to the dark. So what do? How can you speed up that process so that you have a chance maybe of seeing Mercury, maybe Saturn, Mars, maybe some more detail in the corona? There is a way to do that. And I'm here to tell you, I'm gonna get strange looks. I get to see them, which is really fun because I give this talk. I'm giving this talk 4 times a week for the next few weeks. And every time I do this next part of the talk, I get the greatest looks ever. I'm going to start by telling you a tiny little story. And I'm going to bring up a word. I'm going to guess what is in your brain when I say this word. And that word is pirate. I have a feeling what's in your brain is guy with the fancy coat and the dark curly long hair and the beard and an eye patch, right? Have you ever thought of why pirates wore eye patches? Were they all incredibly terrible at battle and they all lost an eye? Every single one of them? No, they didn't. It was actually for science. Most of these ship battles would occur during the day. You're not going to fight at night. It's dark out. You want to fight during the day. So, hey, you swing over, you're the pirate, you're swinging over to that other ship, you've got that eye patch on. And you get over to the other ship, you're fighting folks, and, well, you got to go down below deck, where it is dark. And you got all these guys down there who don't want you on their ship, and they're going to try to fight you. And you need to be able to see them. Because if you go down into that dark hold from this bright sunshine into a dark room, what's going to happen? What are you going to say? No, everybody, let's wait for half an hour so my eyes can adjust to the dark. No, you've had an eye patch on for about half an hour. And when you go down below the hold, you're going to take the eye patch off, or you're going to switch it to the other eye. And you will be able to see with this eye now everything that's going on in that darkened room, because this eye has adjusted to the dark. So this is actually a technique you can do for eclipses as well. So for a total solar eclipse, if you want to maximize your chances of seeing detail, maybe some of the dimmer planets, put an eye patch on about half an hour prior to totality. Yes, you will look like a goofball to other people, but please do not spend a lot of money on this eye patch. Just go to a costume shop or a party store. Just get a cheap one. Bling that thing out, decorate it. And when you are there and you're seeing stuff that everybody else isn't seeing, everyone's going to wish they had an eye patch too. All right. So there are dedicated solar eclipse chasers that absolutely bring eye patches. So you can put it on either eye. It doesn't matter if you have one eye that's better than the other. Just put the eye patch over the better eye. And then during totality, just take the eye patch off. And that eye that'll help you see the detail. All right. Or you can switch it, either one. All right. And every single time I do this, I get the looks of, why the heck did anyone not ever tell me why pirates wore eye patches? That has never come up. It's because all the pirates knew to do it and nobody wrote it down. So if everybody knows it, they're not going to tell you something obvious like that. So anyway, all right, getting back to totality. Totality ends. And the moon is starting to slide away from the sun, and the bright part of the sun becomes visible. But the first bit that becomes visible is shining through a deep valley on the other side of the moon. And that particular side is a side where you've got one bright spot of light, and that's called the diamond ring. And so if you see that, totality ends, the diamond ring becomes visible, count to yourself, 1, 1,000, 2, put those solar glasses back up. Right? Do not stare at the sun. But if you happen to look for a second or two, it's not gonna kill you. Just don't stare at it for long periods of time. All right. I'm going to switch the view of this screen share. Give me a second. And hang on. That's why. Get rid of that, and then get rid of that, and that. Nobody needs to see the news. And give me a second. There we go. All right, I'm gonna do a new screen share. And all right. There we go. Okay, so here's a resource. Those of you, anybody who wants to know what exact timing that you'll have for the eclipse based on where you're going or where you're going to be, if you're going to be here, go to timeanddate.com. Timeanddate.com. Then the sun, moon, and space dropdown. April 2024 total solar eclipse. Click. Scroll down. Map. Click. Over here, the little maximize button. Click. All right, now we've got a map that you can click on, and you can also zoom in. So let's say someone is going to Carbondale, which I think one of our online people was. And you can zoom in pretty far on this map. Now, first off, you'll notice the colors disappeared, but it'll still show you the lines. So the solid lines are the edges of the path of totality within a bit of fudge factor there. They might not be exact. Again, this is a good estimation, but the dotted line shows you the center. So Carbondale is going to be near the center line again. So I'm going to zoom in pretty far. Now, this is why I'm telling you to do this, because you can click around and notice the timing over here on the left. So as I click around, you notice the times change. So yeah, you want to do this for as close to as accurately as where you're going to be as possible, because a few seconds will make a difference in when you're going to try to think about maybe sealing Bailey speeds or when totality will occur and all that. So just getting it to the minute is not enough. Trying to get it to the second within 3 or 4 seconds is good. Now, I'm going to be right where is it? Right there. I will be there, which is the football stadium at Southern Illinois University. And so if I look over here, obscuration means how much of the area of the sun is covered, 100%. Magnitude is how much of the diameter of the sun is covered. Notice that number is over 1. That means the moon is slightly bigger than the sun. Hence, the total solar eclipse can occur. Duration is the total duration for the eclipse from start to finish. And duration of totality is the amount of totality for that particular spot. And these times right here are showing you for that exact location. Now notice for Carbondale, the partial eclipse begins at 12:42. Up here, it's 12:51. And so they're going to start to see the shadow before we will up here. So that's why we're all paying attention to the time. And the times I gave you, 12:51 to 3:22, that's for the Northern Illinois, Chicagoland area. If you're going outside of that area, definitely look up the times. Now, one other important thing. I talked to someone last night who is going to Austin, Texas. So let me show you something really interesting about Austin, Texas, which is also really interesting for Fort Wayne, Indiana, and Columbus, Ohio. You see the dark line right here? That is the edge of the path of totality. Which the rest of the city of Austin over here will not see totality. They will in the center of Austin and to the northwest, but not everybody to the southeast is gonna see it. Same thing with Fort Wayne. Fort Wayne is on the northern edge of the path. The southeast edge of Fort Wayne is gonna see totality. The northwest part of the city won't. Columbus, Ohio, the southeast portion of the city will not see totality. The northwest portion will. So definitely, if you're going to one of those edge locations, make sure you're actually in the path of totality. When I talked to the person last night, the look on her face was, uh-oh. Where she had picked out was not exactly gonna be in the path, or at least there was a little bit of possibility that it might not be exactly there. That they went, oh, it's Austin. But not all of Austin's gonna see it. So I encourage folks to definitely check and just adjust where you're gonna be on that day, all right? Okay. While I'm here, I'm gonna show you this website as well. And that is, eclipse.aas.org. I'm gonna jump ahead in my talk a little bit. Eclipse.aas.org. That's the website of the American Astronomical Society. The reason I'm showing you this is there's a lot of great information here, maps, explanations, all that stuff. But let's say you have family members in about a week who are gonna flip out because they don't have solar glasses and you do, and you don't have enough to send to everybody. So they need to order them, which you're going to go home and you're going to tell them, order them right now. So they actually have time to get them. So go to this website, eclipse.aas.org, suppliers of safe solar viewers. Click. Do you remember all the nuttiness in 2017 when on the giant website, the giant vendor website with the name of a giant rainforest in South America? When the counterfeit glasses were discovered and they pulled all the solar glasses from the site, legit or not? Yeah. The counterfeit glasses have been on sale for about 2 years. They're out there. I've talked to people in the last week who absolutely realized they purchased counterfeit glasses. How do we know that they purchased counterfeit glasses? Because we went to this website, this particular page, and the name of all the actual legit vetted by an astronomer safe solar glasses, these are all here. And the name of the company that was on that she purchased from, it's not on this list. If the company name is not on this list, assume it's counterfeit. It's the only way, because you don't want to mess with your eyesight. And so each of these is a link, and you can click on each of these links and go to each of these web stores and purchase glasses if you have to get more. You might have to purchase some minimum amount, like 10 or 20. I guarantee you'll go through them. Somebody will want them.
There's not
But
a store that sells locally.
sorry,
There is not a store that sells locally.
there are. So North American large retail chains. So Walmart, Lowe's, the various others. What's that?
Walmart.
Yep, Walmart.
Myers.
Yep.
Tons of them.
Exactly. Yep. And a lot of people don't even think of going to the grocery store and getting them. So definitely get those. So H-E-B, Walmart, Meijer, I know we don't have H-E-B up here. For folks going to Texas, then you'll see H-E-B. Look at this one, Cracker Barrel. Ah. But they have that little store in the front, of course. So anyway, and all of the dealers here as well. So importers and dealers, all of these are the legit ones. So an astronomer from the American Astronomical Society went through all the testing results and figured out which ones were real and which ones were sending him fake counterfeit test results, which several of them did. And so he compiled this entire list. There may be others that are legit. It's just they hadn't gotten him the information by the beginning of February. So they closed the list by the beginning of February. So if you know anyone who's purchased any, make sure they check this list and make sure that the name of the company that they purchased from is actually on here, right? When in doubt, throw them out. And get new ones.
ISO number.
Well, so that's a good point. Thank you for saying that. What you're theoretically looking for is the ISO number, which is an international standard. It's ISO 12312-2, and it might also say colon 2015. It might not, but that certification is for safe eyewear to be able to look safely at the sun, essentially. However, there is no central repository of anyone keeping track of whether or not these manufacturers actually meet the standard. Anyone can print that on their materials.
Oh, wow.
That's something that early on in 2017, we didn't realize that was going to be an issue. We started to tell people, yeah, look for the certification. And then we realized anyone can print it on there. And they were also counterfeiting the certification. There were people putting counterfeit test results online, claiming them to be real. There were people putting test results, just putting a certification that wasn't even for safe solar eyewear. It was for something else. One of them was like for food related, but they went, oh, it's a standard, nobody will know. And there were people also counterfeiting the manufacturers' names, the logos. There are people right now saying, oh, I'm selling NASA's glasses on the big giant website. NASA doesn't sell glasses. NASA doesn't sell anything. NASA spends money. NASA does not take in money. The only governmental organization that takes in money is the IRS. Everybody else spends it. No, I'm not being facetious. I'm really being serious. So no governmental entity takes money. Just they spend it. So that's why I tell people, if you think you're buying legit NASA glasses, well, someone is probably either counterfeiting them or selling glasses that they got for free, because NASA's been given away by the tens of thousands. So anyway, just wanted to point that out. Okay, going back to Zoom. Back to my PowerPoint here. There we go. I'm gonna go forward. All right. Other ways for those of us, especially who are only going to see the partial solar eclipse, but also for those of you going to totality who also will see the partial eclipse phases, there are indirect ways of being able to do it. And that is especially using a pinhole projector. Get anything with a pinhole in it. The pasta strainer. All the holes in the pasta strainer become individual holes for projecting indirectly an image of the eclipse done onto the ground. So that's what this is here. This is, we have some lights at work that, some can lights in the ceiling, so about 8 feet up. And these particular lights have 5 LED bulbs in the shape of a star. And we figured out, walking underneath these LED bulbs, all you have to do, now people already knew to do this, but we did this with these lights. Put your fingers in a waffle pattern and line up the light with your fingers and make little pinhole spaces between your fingers. And you'll project an image of the eclipse for each of the pinholes. It'll project down onto the ground. I did this in 2017. It was brilliant. It worked really well. But what you're seeing is each of the LED bulbs. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you're seeing individual images of those bulbs. So these pinhole projectors work great. And you don't need anything fancy, just your fingers or pasta strainer or the pegboard stuff in the garage that you hang the tools off of, or even an index card with a pinhole in it. All right. So definitely use that as another way to indirectly see an image of the solar eclipse. This is a legit image. This is from 2012.
I love it.
If any of you do this, I seriously want to see pictures. I am not kidding. I want you to tag the Adler Planetarium. If you get solar eclipse, partial eclipse images using food, we want to see it. So please do that. I'm gonna guess they probably took a little push pin or a little needle or something and cleaned the crumbs out of the holes. You might have to help it out a little bit. But this is a legit image from a solar eclipse that occurred in Japan. So this is from 12 years ago. So this is, just beware of food allergies if you're passing the food around, all right? But the solar glasses themselves, the way you use them, and actually, I'm gonna come back to that in just a second. Oh, but that's right. I did that part. I have screenshots in case I don't have internet access. I'll come back to this in just a second. If you need a solar filter for a camera or a telescope, definitely buy it this week. You will not have time to get it manufactured and shipped. But I'm talking about a DSLR camera or a telescope. I am not a shill for this company. I purchase solar filters for the telescopes at work, and I get them from this company, and they make great stuff. They use the same material that's in the solar glasses. It's perfectly safe. But if you need them, you are rapidly running out of time to be able to buy them. Yes.
So you can wear glasses and look through a telescope?
No, thank you for saying that. Because then if you point a telescope at the sun, you have the full force of the sun with the magnified light shining on this flimsy piece of material that will melt instantly. And then you will end up, you will not be able to get your eye away from the eyepiece fast enough. So you need a solar filter for the telescope itself, and it goes over the front of the telescope. So it blocks out the light before it even gets into the telescope. So that's a solar filter for a telescope. Same thing with a DSLR camera. The filter goes on the main lens on the front, and the filter will depend on the manufacturer and the size of the lens and all that. But they've got all that information on their site. You do not need a telescope to enjoy a solar eclipse. That's the great part about solar eclipses. The amount of equipment you need is minimal.
I thought maybe to see those planets. you know, those.
I personally wouldn't, just because, especially for those who are not traveling, you won't see the planets in the sky. It won't be dark enough. But if you are traveling, I just wouldn't waste time during totality to see planets that you can see at night. So don't even bother. And it's one less thing you have to drag with you. A lot of people ask about welder's glass. Yes, you can use welder's glass to safely view the partial eclipse. 12, 13, or 14 are the numbers of shades, the shade numbers, sorry, that allow you to safely view the sun. Expect to spend a lot more money on a piece of welder's glass. Expect the welding supply companies to run out. Expect them to only have probably shades number 12 or 14. 13 is kind of rare. Expect to find counterfeit welder's glass on the big giant vendor website as well. So I tell people, if you're gonna, if it's last minute and you're trying to find something to safely view the sun, call the company, go into the store. Don't get it online, because you may very well get counterfeit materials there too. And good luck for all of us to be able to see this. Now I'm going to go over real quick. I'm going to stop sharing.
Is the Adler going to do something special?
Yes, so the Adler Planetarium will have telescopes out. We have special rigs that one of our volunteers created. He 3D printed and created these rigs that go onto small telescopes that basically create an image of the sun that's this big. It's fabulous. It allows you to see sunspots and detail, and it allows you to step back away from the telescope. You don't have to get your eye in exactly the right spot. And it allows you to step back away from the telescope and see it from feet away, and you can take a picture. So we noted in 2017, that was the thing that people wanted to do more than anything, was to take a picture of the partially eclipsed sun. And so this time around, we're doing that, but also you can get a crowd of people around and everybody can see this image all at the same time. The problem with a telescope that you have to put your eye up to, each individual person has to get up to the telescope, and it takes time. So rather than do that, we have this special rig that is really great. And so we're going to have several of those out. And basically, we're just inviting people to come on down and commune with the sky with us. Enjoy the sky, enjoy sitting outside and watching the eclipse as it occurs. Weather permitting, of course. So we'll know hopefully a few days prior if the weather's going to cooperate. It didn't in October. We hope we have better luck in April. All right. Oh, and that event will run from 12:30 to 3:30 on Monday, April 8th. And then you can visit the museum, get your tickets as normal online.
What are the tickets running?
I'm sorry, what?
How much are the tickets?
It depends on who's buying them. So definitely go out online and check the ticket prices for that. Depends on if you get museum admission only, you want to see a show, all that kind of stuff. Okay, so how to safely use solar glasses and solar viewers. They work exactly the same way. It's just that they're shaped differently. And the silvery side faces toward the sun. The black side faces toward you. Right? So you put this in front of your face, then you look up at the sun, and then you can look down and then take it away. So as long as you aren't looking up at the sun first, or don't look up at the sun and then take it away, and then look down. So put it over your face, look up, enjoy, look down, and then take it away. Okay. The solar glasses work exactly the same way as the solar viewers. It's just that you put them over your face. You would put them over your glasses if you wear glasses. Then look up, enjoy, then look down. If you have them left over from 2017, you can use them, provided you kept them dry, safe from punctures, rips, tears, folds, pinholes, all of that. So in order to check them, if you haven't looked at them in a while, get your phone flashlight out and shine it through. And if you see any bright spots of light or anything looks out of the ordinary, then throw it out. Okay. You don't want a pinhole of light coming through these because that becomes a pinhole projector. You're creating a focused image of the sun that would potentially get onto your eyeball, and you don't want to do that. So just be careful. Again, when in doubt, throw it out. And for the solar glasses and solar viewers, the material does not expire, but you just need to take care of it correctly. Okay. And then one last thing, because everybody wants to take pictures, right? So again, for those going to totality, do not take pictures of totality. Let the professionals do that for you. Actually, I'm going to use these over here. So let the professionals take pictures of totality. You have precious little time. But for the partial eclipse, what you can do is take your phone out of its case, because I have a case here, and it creates a little tiny bit of space in between the edge of the case and where my lenses are for my camera. So I want to take my phone out of its case, take a pair of solar glasses and tear it in half. I know, seems sacrilegious, but what you want to do is then take the silvery part and have it face out, and the black part faces toward all your lenses. Make sure all your lenses are covered. Don't partly cover, right? Fully cover. Tape this stuff on. Don't take it off. Designate one phone for taking partial eclipse phase pictures. Then you can put your phone on a tripod if you have one for your phone, but you don't need it. You can brace your arms on a table or on a fence post up against a tree, just something to keep your arms and hands from shaking. So then you turn on your native camera software. Whatever phone brand you have, turn on your regular camera software. Somewhere in your settings, and you'll have to look up on how to do it, but somewhere in your settings, you want to look for a setting called HDR, high dynamic range. What that tells your camera is, if you turn that on, that you've got a wide range of brightness in that image. You've got the bright sun and literally black around it, nothing else. So you're telling your camera, hey, this is okay. And so you've got the solar filter material taped on, native camera software, HDR, turn on the video setting, brace yourself, and take a video for about 10 seconds. Surely a frame out of that video of 10 seconds will show you the partial solar eclipse. You might have to expand it to zoom in, hence covering all your lenses. Each of these individual lenses does a different zoom factor. So you don't want to zoom in and accidentally use the lens that might not be covered by the solar filter material, because you'll ruin your lenses, because you don't want to point these at the sun either. But Make sure everything's all covered, zoom in. You might also have to reduce the brightness of the sun. You'll tap it and then drag your finger down. If you've never done that to reduce brightness, try it. That's at least on an iPhone. I don't know if you do the same thing for an Android, but, so you would tap the sun and then tap, you don't need to see my cats. So tap the sun and then drag the image to reduce the brightness on the screen. So zoom in, reduce the brightness, take a video, or in some order like that. And hopefully you'll get at least a frame out of that video. You don't want to take the individual images, because have you ever taken a picture or tried to, and your camera just starts focusing in and out, in and out, in and out? It would probably do that. So taking a video, you have maybe a little bit less of a chance of that happening.
So are you looking up when you do that, or are you just looking down?
So you're looking at your phone screen. So it's protected from the sun.
Yeah.
You're looking at your phone screen. If there's any chance that you're gonna look up at the sun, just have your glasses at the ready. And so make sure they're over your eyes. But chances are you're looking at your phone screen. So it might help to have a brimmed hat so that you're not accidentally looking up at the sun, and it might be a little bit bright. So that would help. So thank you. That was a great question. All right. Questions? I'm gonna check in the chat real quick to see if we've got
There
questions.
was one question about the recommendations for buying glasses.
Ah, yes.
We already answered.
Excellent.
Yeah.
Great. And I think Stacy went to Southern Illinois University, I think. So she says alma mater, question mark. So that's cool. All right, questions here. And I'll probably have to relay the question just to make sure the microphone picks it up. Yes.
I want to see more Bailey's beads than not see them.
Mhm.
Am I better off at the center of totality or near its edges? Or is there any way to predict where along the path of totality I should place myself so I maximize the chance of seeing Bailey's beads?
Bailey's beads is you probably want to place yourself more near the center of the path of totality to have the best chance to be able to see them. Yeah. Because if you're off near the edge, it would just, let me think. It might not matter. Now that I'm thinking about it, it might not matter. I mean, you're probably going to want to put yourself near the center of the path of totality anyway to have the most totality time. I don't think it matters.
See, what totality seems is pretty much the same the entire time it exists.
Oh, yes.
So, but Bailey's beads are
Short.
short
Yes.
and different every eclipse, depending
Yeah,
on where you
yeah,
are.
yeah, it might,
So
yeah,
if I've seen it before
yeah.
and I want to see Bailey's beads this time,
You are the first person I've ever come across who really wants to see Bailey's beads. That's really cool. No, actually, because I haven't seen them. Because the solar eclipse, the totality that I saw in 1999, by the time they were done, that's when I took my solar glasses off. So I did not actually see them. So you have given me an impetus to potentially try to see them this time. I don't think it matters where you're located. I don't think so. But I'm not 100% certain of my answer. So we may want to do a little research to figure that out.
I've never been able to find anything online or anyplace else.
Yeah.
that talks enough about this.
Yeah,
to
that
give
tells me,
anything.
that tells me that maybe it doesn't matter where you're located. Because everybody is kind of like, I don't think it matters
Craters
because,
on the moon are all it's different orientation. Every eclipse during the path of totality in different places.
true, but it might just, I don't know if it's gonna make, I don't know if 20 miles on the earth is gonna make that much of a difference as to
Okay.
seeing.
But arranging myself where on the path of totality may make a bigger difference. In other words, to see.
You mean not the north-south?
Yeah.
Or you're talking,
Along the length of the.
Oh, gosh.
totality.
I would say probably more near the center of the path, which unfortunately, unfortunately, it, at least in terms of driving distance, is Mexico. So but Texas and Arkansas and Missouri, that general vicinity would be the closest location to the maximum point of totality, which is in kind of northeastern Mexico. So that's the closest place in the US to be able to see that. So now that we're chatting about it, I would say probably near the maximum duration point, which is that subsolar local noon point when the sun is highest in the sky to be able to then see the eclipse. So I would say shoot for like Texas, Arkansas, Missouri.
Well, yeah, can't go that far, but.
Then Southern Illinois. I'd say get yourself close enough. And I'd say Southern Illinois then is your next best bet.
Okay.
Yeah.
Another question.
Yes.
I know you're into the astrophysics of this, but what are the effects that you can watch for with animals,
Yes.
birds, and all those other things
Yep.
that happen, which you tend to miss if you're gonna focus?
Sure. So what do you do for all those animals and stuff? What do they do during eclipses? And the answer is there's not a lot of research about what happens, but there is going to be some research done during this eclipse. So what people have anecdotally noted is animals do what animals normally do during nighttime. Cows lay down in the field, or they might walk back to the barn. It just depends on what their normal nighttime routine is. Birds might roost in trees, or they might fly to lakes, or crickets might start chirping. Anecdotally, there was a zoo in South Carolina that noted different animals doing different behaviors. Like the giraffes started running around crazily. The tortoises, there are no children in the room. The tortoises got very friendly. But they're not sure if some of these behaviors that the zoo noted were just one-off, just tortoises being tortoises, or was it something due to the eclipse? And so for this eclipse, so that was in 2017. So for this eclipse, the Fort Worth Zoo is going to station researchers all over their grounds. And I believe a few other zoos are going to do it too. And they're going to see some of the same animals during totality and see if they're gonna write down or video any interesting behavior that these animals are doing, because we don't really have a lot of hardcore, real scientific research about this.
That would brings me to the second part of the question. If I wanted to bring the right animals to observe some strange animal behavior, which animal should I bring?
Well,
Should I bring like an Should I bring like?
tortoises are really
Should I
interesting.
bring like, should I bring my kids?
So I would say the chickens would probably be interesting, but I don't know if you want to travel with them. Dogs and cats generally don't care. I get asked sometimes, do we need solar glasses for our pets? And the answer is no, they're not. They're too smart to not look at the sun. They don't know what's going on. So I mean, it's up to you if you want to actually travel with animals or go to the Fort Worth Zoo and watch totality. I would say if they're actually going to do something like that, if they're letting people in that day, go hang out at the zoo and go bother their animals and go see what they're doing. I think that would actually be pretty awesome. So there you go. Yes.
Have you heard, have you heard of places like the Fort Worth Zoo?
Mhm.
Where they are definitely gonna be putting things online that you can kind of like sit down and watch? what
Yes.
it is that
Yes, so watching totality or watching the eclipse as it's occurring, so a live stream, that sort of thing?
Yeah.
Yes,
I
so,
also heard that, in fact, I think I heard it about carbon dioxide,
mhm,
that, there's gonna be like a satellite hookup, so if it's cloudy, you'll be able to see the.
fingers crossed, yes. So what we're planning in Carbondale is gonna be one of the sites that NASA is gonna pull feeds from. So NASA is doing a big eclipse broadcast online, so nasa.gov. But what they're gonna do is have totality occurring at different locations at different times and just go to those locations as each one is occurring. Now, in Carbondale, we've also got the benefit of one of the physics instructors at the university is going to be mobile. And so he's gonna plan, if it's not gonna be clear in Carbondale, if the weather's looking really iffy, we're still gonna have a big fun in the football stadium, but he's gonna try to go to a location somewhere within a few hours driving distance and get on a satellite hookup. He's got a Starlink hookup, and so he's gonna be able to broadcast from his telescope to the Jumbotron in the football stadium. So no matter what, we're gonna try to see totality. We just might not see it above our heads. But no matter what, it's gonna get dark. So that's kind of cool. So that's what's going on for that. So NASA.gov, the Exploratorium in California is also planning an eclipse broadcast. And last I heard, they're gonna be in Mexico. I'm not 100% certain if they are. I don't know if they decided to be in Mexico or in Texas. So, but the Exploratorium in San Francisco, you can check their website for information about their broadcast. And the time and date website that I showed you before, they will have a broadcast as well. So you can go to timeanddate.com, and the sun moon section that I showed you, right below where it said April 2024 total solar eclipses, it says live streams. Just click that and they do lots of live streams, lunar eclipses, solar eclipses, the whole bit.
Is the library doing anything?
Yes, we will have the live stream from NASA. Are we doing the viewing? Megan, correct me if I'm wrong.
We're not doing like an official viewing, but we're anticipating, since there's nice open space out back here that belongs to the park district, we're anticipating that people are gonna come and view it. We're not doing anything like official, like everybody line up and go outside, but.
If you want to come and hang with other folks who are probably going to want an open space
Yeah,
free from trees. and
NASA
stuff.
live stream will be streamed in the library, so you can come in the library and see the NASA solar storm.
Cool.
Yeah.
Very cool.
I'm gonna be real with you, if it's not cloudy and we get a good view, I'm working on that day at that time and I will be outside.
Me too. I'm working too, so we'll be outside.
There you go.
probably, so-
There you go.
We're all probably just gonna walk outside for a few minutes.
Yeah, exactly. Yeah. Yeah.
From the library.
Yeah.
Question for the library.
Mhm.
Do you have lights that go on when it gets dark outside, security lights? They ruined my viewing last time.
Okay.
When I didn't realize that street lights were gonna come on and everything else was gonna lighten up.
It shouldn't. So was that here for?
No, North
Oh.
Carolina.
Oh, that's why. Here, it won't be that dark. It won't be that dark.
I was gonna say, this is in the afternoon.
Yeah, this,
Yeah.
well, but also 6% of sun will still be visible. It won't be dark enough for the streetlights to
It
come on.
was dark enough from the occasion I saw.
Yeah. No.
Street lights came on.
Now, that might be someone who's a little overzealous with the settings for the streetlights, but no, they should not come on. It won't be that dark. You won't, in this area, you'll have a tough time noting that it looks any darker in the sky. It may be a little darker. It's just that your eyes are gonna constantly adjust to the dark. And if the streetlights do come on, you've still got 6% of sun visible. That's plenty to light up the area. The sun will be brighter than the streetlights, for sure. Yeah. Yes,
I forgot my question, but it's great.
all right, that's all right.
Yes, yes.
There you go. I knew if we
The,
waited, we could get it.
What's the period of time, totality in Carbondale to totality in, Indianapolis area?
Let's check. So I'm gonna look it up. I'm not gonna share the screen, folks, at home. I'm just going to look real quick. So period of time, you mean the actual time of totality?
From.
Or the duration.
One there, how many minutes?
How many minutes in between? Yep, so, 1:59 PM for Carbondale, and, cause that I know. Indianapolis is, local time is 3:06 PM, which is 2:06 PM Central Time. So 3:06 PM local time, because they're in the Eastern time zone. So that would be about 7 minutes in between.
Another way to ask that question is Delta has a flight
Yes,
Take.
yes.
How fast is that plane gonna have to go? In and out of the path of totality?
It will not be able to stay in the
It can't
path
go
of
that fast.
totality. It can't go that fast.
It can't
Yeah.
go that fast.
The
That's what I
shadow,
wanted.
yeah, the shadow is traveling, well over 1,000 miles an hour.
Okay, so that was like, they're saying.
Yeah.
Flight, I'm like,
Right.
really, it can go that fast?
No, what they're doing is they're getting above the clouds. That's why the flights are something that people like to do. And hopefully they're only booking half of the plane. Right? Because you've only got a few minutes. Now, the other possibility is they're gonna turn the plane around, but do they have enough time?
And that's what I was basically
Right.
getting, it's like, how fast is that plane gonna have to go?
Right. No, NASA did do a research project in 2017 where they were gonna fly more supersonic jets or jets
Yeah.
that could go a
I know
lot
that,
faster.
but
Yeah.
the Air Force does,
Right,
yeah.
yep, and
The
when
commercial plane, I'm like.
right.
really?
when the Concorde was flying, they used to fly that into solar eclipses too.
Yeah.
And I know people who have been able to spend longer periods of time in totality because the Concorde could keep up, or at least it extended the amount of time
Yeah.
of totality. Yeah.
I got a question.
Yeah.
What's your degree?
Physics and astronomy. And for my bachelor's degree, and education for my master's degree. So I straddle both worlds. So I get to learn about the science stuff and I get to talk about it in really interesting ways. I get to bring it to a level that people can enjoy, hopefully. So, any other questions? Are there any other Zoom questions that I missed? Are we all good? All good? Are y'all good?
Where'd you get your shirt?
Oh, sorry. This is the Adler staff shirt for the Eclipse. So,
Oh, nice.
yeah, we do have shirts that are similar to this, just not exactly the same. Because we wanted to be able to identify our staff and volunteers among crowds of people who might be wearing a similar shirt. So anyway, but yes, you have the last word. Go ahead.
I would expect people, there are gonna be those whose eyes are damaged on April 8th.
Probably.
Are there many?
Not many. So what happened, so the question was, are there gonna be people whose eyes are damaged because they stared at the sun? And the answer is probably. Because we can say till our faces are blue, don't stare at the sun. You don't stare at it any other day, don't stare at it during an eclipse, but people do it anyway. We hope they don't. We hope they get the word out, but, or hope that we get the word out to them. What happened in 2017 was it was documented that we could find about 36 cases of eye damage due to people staring at the sun for too long. And what happened was that the ultraviolet and infrared light is the light that you actually really have to really worry about, along with the bright part of the sun. And that's why the counterfeit stuff for solar glasses is so dangerous. It might be blocking out visible light. It might still be letting through ultraviolet and infrared light. And you don't feel, even if you're staring at the sun unprotected, you don't feel pain because there are no pain nerve endings at the back of your eyeball. So the burn happens and you don't feel it. And so what people were noting after the eclipse, after they stared at the sun for a while, was they had this shadowy spot that just wouldn't go away. And so they went to the eye doctor, and the one case that I remember vividly is there was a woman who stared at the sun long enough that she got a crescent sun shaped burn on the back of her eye that was visible in the images of the back of her eye. You could see which part of the eclipse she was looking at. It was amazing. I don't recommend doing that. Don't find this out for yourself. But yes, over time, your brain can compensate. Eventually, your brain learns to ignore that strangeness in your field of vision. It's still there, but your brain ignores it. Whether or not your eye can fix itself, I don't know. Just don't find out. But I would not be surprised if it's in the few dozen range. Again, no children were harmed by the last eclipse, which is great. It was just adults. So, are we all good? All right, thank you so much. Good luck.